Afternoon, everyone. Welcome to the first of your classes today. So thank you for joining me. This is the performance testing class. So the goal we've got is that we're ultimately going to go and break my own website. So we'll give that a go at the end of this. But a lot of theory. We'll do a bit of mix of a theory and a little bit mix of practical stuff. So. Has anyone got their laptops? Because if no one, it seems like no one's got a laptop ready. So, do you guys want to take part of the practical, or would you just rather watch? I'm happy either way.
I saw that you gave the option, so I thought I'll just watch.
Okay, cool. I think we'll just go for watching then. Cool. So, a little bit about me. I am a 3.4 rated tester. That number has a very special memory for me. We had an internal review from SFA at the end of the performance testing work we did for them, and we did inspire some good confidence. It was SFA are, as someone in this room knows, a very tricky client, and they do not inspire confidence when explaining. So we managed to build up some confidence in the performance of a major software update for SFA. So yeah, really good. It's 3.4, but it has a special place in my heart. I actually also have a Bachelor's of Science. I studied at Leeds, Beckett. Yeah, good. That's me. So if performance testing is actually a career choice, there are dedicated jobs solely for the purpose of performance testing. It pays quite well. It's not a disrespected career or anything. And being a performance testing, I find doing performance testing is quite rewarding. It's really satisfying to. The most satisfying part for me is you've got an application that you've performance tested, and you feedback that information, and then some changes happen, and it's a bit faster next time. That's actually a really great feeling. It's just genuinely something I really enjoy doing. There are some downsides to it. Oftentimes, you can often be the source of blame if there are performance issues in production. That's just a side effect of doing the role. And sometimes things are quite hard to find because if you're doing performance testing, you're trying to replicate production-like traffic. So it can drive you slightly mad because you've kind of got to set up a real-life production scenario, sing something, and try and find an output from it. So quite a lot of investigative work needed doing. And I've put don't use JMeter because please don't use JMeter. We're going to use K6. JMeter, for the record, is a very old-school tool, and it's fairly awful. It's very good for a UI. So if you don't have much coding experience, it is the best tool because it's got a GUI. But at the same time, you usually end up having to code in it anyway because you've got to write scripts that transfer things across steps and stuff like that. So that's just a note on JMeter. Gatling is Gatling the? So I've not actually used Gatling. Is one of the ones I've not used. That's a YAML-based thingy, isn't it?
I think it's still based on one of the Java.
Yeah.
I don't think it's Java, but it's written in one of the Java.
Yeah. So
languages.
Gatling may be a Java-based one, but there's quite a lot of them. So there's a .NET one as well. There's Mbomber if you've ever come across it, and there's Python one. There's one for every language. We're focusing on K6. Yeah. So jumping back a bit, when you deal with performance testing, we have something called. We often have maturity models when dealing with clients, when we introduce ourselves to new clients. And for performance, it's actually fairly simple what the ask usually is, but the means of achieving it are probably the difficult part. So oftentimes a client if for example, they would say, this seems really slow, why is it slow? And you build up a level of how do you make sure it's not slow when you put in a new release, which is what SFA was really worried about. And then you look at like a more repetitive framework, maybe integrate it in your CI/CD, and then oftentimes you move on to optimization. So a lot of the work we're working on the current NHS project I'm on, we oftentimes are looking at ways of making things quicker. So for instance, we have a login service, and the login service makes multiple calls to the same thing to get the same info, but do slightly different every time. So you can do like big optimizations like that will save you quite a bit of time in a service response. All good? So the goal of using something like Gatling or something like K6 is you're hitting something hard. Doing something once actually tells you still a little bit about the system, because you learn one small thing. You still learn something because it's still using it once, but software has a habit of, until you hit it quite a lot, it's still kind of in like a warming up phase. It often has slow starts because your computer's got to like put things into what's called memory, where it will like remember things that it did last time, so it doesn't have to do them again. And so after hitting it hard for a period of time, you get the response time of what like a production user would use. So it's things like that. So like I say, hit it a lot, you're going to learn a bit more, and then
Faster because it uses, depending on the language.
Yeah.
That has a just-in-time compiler, JIT. So the more you execute the same thing, it will find the hot paths and it will do more compilations.
I think, yeah, so yeah, .NET will use JIT to make things faster, but I think there's other languages that have similar optimizations, I assume. I don't know that level of detail about each individual language, but I think some languages will share some form. I think memory optimization will probably be a part of many API frameworks, I'm guessing.
And if there's a database involved, that might have an execution plan that it runs first, and that first hit is slow, and if you hit the same query again, it's faster.
Yeah, so database execution plans, which is hitting a database, and then you hit it again, and the first time it's preloading things, I assume that's the thing.
Working out what the best way to execute is.
Yeah, okay.
So it's not as fast the first time, and then once it figures it out, it tends to be a lot quicker, and there's certain things it can cache and make more optimized.
Yeah, so databases have a lot of things in them as well, and most applications have a database. Yeah, many different types of hard hit. So you've got different types of performance testing. So yeah, it's oftentimes you have different types. So you might run a test for a lot longer. You might run a test for a small period. Okay, so K6 part 1. I think everyone's just watching, so I will just show the test running. So if I get this on here. Oh, there we go. So this is a K6 script, and this is my API. So not much at all in this, but all I'm doing is I'm just getting the first item from my service. So it's a application. I'm going to get me the first one, and I'm going to call it a lot. So if I get rid of that annoying pop-up, and I K6 run. So this test is configured to do 1,000 users. I'm going to leave it running for 20 minutes because I want to do something while it's running. So if I run that.
Just a question. With each K6 test, do you hard code each API get call what you want to do?
So in terms of like so the question is, with each test, do you hard code each endpoint?
Yeah.
This is JavaScript, so you have most of the JavaScript library, so you could read from a CSV file, you could dynamically put data in there. This instance, I've just made it really, really bog. Did I not? Oh, there we go. Well, we'll do that again. Control S, curses. So we'll do that again. So now what I'm doing is I'm hitting with 1,000 users, imagine 1,000 people all in a room, and they're all calling, they're all using my website. So imagine 1,000 people and their computers in a little building. So one thing we often look at is statistics of the server. So I'm going to log into my server, which I think is It's this one here. If I can just hit the arrow keys properly. So I'm going to use a tool called htop. That is effectively Task Manager if you are in Windows. It's just keeping track of what's going on the machine. So you see this here, that is my server, and with 1,000 users at once, the CPU is hovering at about 30%, and the memory usage is up to 22, and that will give us an indication of what my server's doing. So there's all sorts of things going on here, but all I really care about in this instance is these two, and yeah, it's just those two really, just the CPU and the memory. There's other statistics.
That's literally the health of the server though, isn't it?
Yeah. It's one of the things you keep track of. You keep track of the thing on the server side and the client side. So that's the.
So, Robert, what point would you know that you've got an issue with 1,000 users?
So I'll get to that. It depends, because obviously you might have, you might want to not go maximum, but if I just cancel, so I've lost my mouse here, it's a bit tricky this. So I go back to this. So you measure things, and you measure quite a lot of things when you're doing performance testing. So you see, on that server, we saw the CPU was at about 21%. If it gets to 100, that's bad because you've maxed out the PC. But there's a bit of nuance to that question. Obviously, if you go into 90, you might think, maybe we might want to whoop that sort of question. But it's kind of like you would define what your expectations are before going in.
You would set boundaries because actually, if you were looking to better utilise that server, you might want it to use a lot of CPU because otherwise, if it's only using 20% of the CPU that you're paying for, then why are you paying for that much CPU?
And that is exactly why things like, Jake just mentioned there that you might not want to have a beefy PC to do something really basic. That is exactly why stuff like serverless exists, where you have something where it's really small if there's only one user, but if loads of people suddenly come in, it'll scale for you automatically. So that's the sort of thing that would be really helpful in that scenario. You got memory as well. So for those who don't know what CPU is, it's in a very simple layman's terms, it's the thing that does things in your computers. There's so much depth to it that you'd have to be an electrical engineer with a master's degree. Unfortunately, I'm not that. So, so it's CPU is the operation, the thing that moves numbers around. In a very simple term, sorry Jake, that probably might offend you. Memory is how much it keeps track of things. Again, if that number gets to 100%, bad. Same thing applies to CPU, scale it, you can scale it. Response status is what the server did. So 5xx is when something went wrong on the server, and that typically happens when something's gone wrong, like really bad. So if you're seeing those errors, that means that your server's misbehaving.
It's exceptional responses
Yeah.
rather than something you were planning on.
Yeah. So, yeah, that's why 4xx is watch out, because that can sometimes mean something's gone wrong, but it's more client side wrong.
It's gone wrong on purpose, like it's validated.
Yeah. Yeah. But I've seen, performance testing is weird. You can see 4xx errors even if it's gone, like you've hit it too hard. So it's that sort of, if you're seeing them and you're not expecting them, that's probably not a good thing.
We've also got the 2xx responses as well, haven't we?
2xx is good. So that, yeah, thanks sometimes for mentioning that. But 2xx means it's okay. So that's usually what you're looking for. Disk, which is it's just a hard drive. You put stuff on it. Databases use disk. I mean, if it's full, that's usually bad. Network, so this is about things going across different computers. So I've referenced it as smoke signals, but it's if you've got intimate connected systems and you want to make sure that they're not sending too much info to each other, you've got to keep an eye on that.
Can we test that through performance testing?
Network.
Yeah.
I'll show you in a second. Response time is also how fast the service takes. So these aren't definitive. There may be other things that you might come across in performance testing, but these are the general things you look for when you're doing performance testing.
Would you outline a lot of these metrics, obviously, before you put something live to make sure it doesn't fall over, or is this more once you're testing it to make sure it's not going to fall over? Like, would we try to prevent this before? Does that make sense?
So the best thing you can do is you can, in the product I work on, we set up alarms, which is if that thing happens, tell someone about it, because if that thing happens, it's very bad, and then you have the whole investigative thing of trying to fix it. You can't prevent things being maxed out. The only way you can really prevent it is just make it so big, but ultimately you may still hit that max. It's sort of a bit of a game really, in the sense of you've got to try and capture things going wrong, and it's same principles of testing. The earlier you spot things, the better, but yeah, exactly. Yeah. So, like Jake says, it's observational, keeping an eye on things. If we have memory watchers on lambdas, and if the memory gets used too much or something, we're able to spot that and remediate it in advance, so we can go in and configure the server sort of thing. Because a lot of fixing these issues, the easiest solution is sometimes the best solution of just scaling up. Not always the best solution, but it's usually easy, but it has costs, and it's a very, very, very complicated topic. Yes, exactly. I mean, for instance, yeah, Jake said it depends how deep your pockets are, but if you ever use serverless, it can sometimes be cheaper to have more power because I've got a blog post on serverless. I'll link that in the chat, but it talks about how these things last for as long as you use them, and if it does it faster, you pay less. So you would actually save money even if you have more power, which is complete nonsense to me. Like that doesn't really. It's crazy how that works. Yeah, it's how long you use it for, and that's kind of getting into lambdas and serverless and all that. Yeah, so Dan asked, how high can K6 go? How many users can you go? You can set it as high as you want, but ultimately you're going to hit a problem where the client actually runs out of ability to do so. Like 1,000, I could spin it up to 100,000, but I don't know my machine's running at 90% RAM all the time. I don't know what it's going to do. And
I just thought in terms of the product itself.
Yeah, and sometimes that is actually a valid use case as well. So you sometimes distribute your performance test over multiple machines, and you would have a master controlling the different nodes, and it would coordinate the performance test. For most cases, you probably don't need to do that. It's more extreme. But there is. I have seen it before. I worked at a credit bureau a few years ago, and that was actually a thing where they had distributed load, because how many people are looking at their credit report on a daily basis, sort of thing. So K6 Part 2, you can do other things as well with K6. So you can say, so K6 Part 2, we now have a put and a post. So this is different now, because this gets a bit more involved, because instead of just going to the service and grabbing something from it, we're now starting to put stuff in the database, because we're uploading things into the system. So slightly different, more and more involved performance tests. But if we bump this up to 10,000, stop this one, and then if we do this part 2, I'm actually not going to go 10,000. Yeah, thank you, Jake. Jake just told me to save it. So, as you can see, I've actually got some logging this time, so you can see that the logging is a sign of it took a bit of effort to get this one to work, because I wanted to say, oh, it's blowing up. That's interesting. Let's have a look at that. I wonder if the disk is filled. This was likely because of requests. So this is actually a problem. I have broken my API. And yeah, that was the title, yes, but I wasn't expecting it to break the sale. I bet you know. That was, so as you can see, so we can't transfer. So this is now where I would go. First off, does my actual application need to support 1,000 users? Probably not. But what this means is that if it did, then I would start having a look at the server to understand what was going wrong. So if we go back to here, I wonder, and this is kind of the investigative process of trying to figure out what happened there. So I'm not going to try and debug, spend too much time. Oh, there you go. Oh, that was a maxed out CPU. But it's that sort of investigative process of trying to figure out what went wrong and kind of the detail and that. So I'm actually going to just check my API still running.
It's not.
Is it not?
Oh, no, sorry. It's not being hit anyway, because it would be at the top of the list, wouldn't it, if it was still being tested.
Has it switched down? It's shut down. Okay, well, we'll get that back up and running. So if we go to oh, that's just pressure, isn't it? And then if I do so that's back up and running. Is the API up and running again? So if I just quickly go into here.
In terms of, when you did the htop and looked at the server, on the server itself, can you see any history of what's gone wrong?
Get to that in a second. So I'm just going to check my.
I've got a question. How come then with like all this, nobody's designed something that just tells you what the error is straight away rather than having to go through loads of lines?
In the sense of how I'm debugging this.
Like obviously when you're performance testing anything and you've just got to look through all the errors to find out which ones like made it fall over. How come there's like not something developed that just tells you on the top line this is what's wrong to save you time? Do you know what I mean?
So Lucy asks a good question in the sense of why things aren't simple in the sense of if something goes wrong, why can't you see it sometimes? And the answer is unfortunately you have to hit it very hard, so you are going to get a lot of things. And this is kind of getting into the development side of trying to figure out what's wrong. And it's genuine. This is like, when people warn you about productionizing your software, this is genuinely stuff like this that comes up. Like you come across weirdness.
How would you set up your metrics and your monitoring and observations? Because a lot of the time it does tell you in the error that there's run out of disk, or there'll be something about the disk that it's complaining about, which then will make it easy to actually eventually figure it out. But it has to be logged, and then that log has to be visible, or they must basically monitor the log. So if Rob's API is writing error logs, then it's probably going to be in there as to why it failed.
So Jake just says if I did something, then we should maybe be able to find the issue. I have here. Let me just get this on the screen because I just realised it's not on the screen. So this, my app is hosted in a cloud platform called DigitalOcean. This is like an alternative to AWS for those familiar. And you can see here, over the period of time that my CPU is running fine. My memory hit a spike of about 60, and my disk hit quite a lot, 300 kilobytes a second. But for some reason, my app died. I don't know why. And it will, no.
When we stopped the previous test, that was running for 20 minutes.
Yeah.
Would that have shut down your API as well as a termination?
Sorry, so you're asking if the previous test run could have switched it off?
Yeah, because we cut the previous test short to run the put request into the database. When you ended the previous test, would that have shut it down?
No.
In terms of the termination?
So Dan asks, does the ending the client, so Dan is asking, by ending the previous test and rerunning it again, did I switch down the API? No, the API is running separately on its own.
There isn't direct connection, but if the load was so great that it caused an error, as in like there was a memory leak, and by hitting that endpoint over and over again, the memory got bigger and bigger and bigger, it could have caused the API to fall over, but it wasn't as a result of it just stopping.
And Jake makes a really good point that no matter how much monitoring you have, no matter how best endeavours, the debugging these issues is really, really difficult. Jake talks about kind of like how the stats of the machine look fine, but if something went wrong on the application level, that could have just killed it. I don't know. I'm not going to get into detail.
What error messages in your log about can't transform the JSON or something?
Yeah, well, I could leave the production logs, these logs on, but these will log so much that I won't get into too much detail. I do need to keep going with this. So Jake wants me to fix it. I can't fix it. So we've added the get and post. So performance testing types. So someone mentioned earlier that there's the breakpoint test, which is what we've just done, because I hit it so hard that I just killed it. There's different types of performance tests, and a lot of it's based on expectation of what's going in. So a client will probably have an expectation of saying, oh, what happens to, so for instance, when I worked for the credit bureau, their busiest day of the year was 1st of January because people like to spend a lot of money in January for holidays. So we based our testing on that, and that would have been a stress test of hitting it during that period. Load testing is like general load. You've got endurance testing, which caught us out on our current project, which is if the service is running, if you're running a test for a very long time, does it still behave? And we came across a thing where after an hour, we just randomly started seeing failures because it was lambdas and things that shut after an hour, but that's the sort of thing you would spot with that. And then spike test, which is like a stress test, but instead of a high period of high volume, you would randomly go, oh, nice day, oh dear, oh, nice day again, oh dear, nice day again. So that's the kind of like...
Would spike test be more useful in terms of, like for example, at the end of the financial year, you have a lot of people checking reports in terms of checking if your CPU is increasing as and when you want it to.
So Dan asks a question around the period, like on the January the 1st, like when things are really busy, what type of testing you would do. So when would you do spike? Actually, no, I would do stress testing for that because it's a busy period over a period of a day. So the stress test would be like, so let's say January, what's the busiest hour in January, and then average out that day and then split it across, and then that would be a stress test. A spike test is more like you're working with a company and they put in things into your system, but they don't do it evenly. They just go, here you go, all at once, and that's the sort of thing you would spot with spike testing. Okay. K6 part 3. So this is getting into the measuring side of the client now. So if I go to not that one, this one. So K6 part 3 is similar to, I'm just going to shrink the terminal a little bit so you can see it a bit better. So bear with me. So as you can see, you have all the stuff in there, but this time I've added what's called trends. And these are what keeps track of the things I'm measuring. So I've got one for getting things, one for updating things, and one for putting things in. So K6 uses this concept of trends. Different frameworks use different things, but it's just about measuring actions. There's a million different ways of doing this in the world. Tens of different frameworks for doing these sorts of things. So I'm going to keep this one relatively calm because I need to not break things. So let's just try this again. We have to sit around for 30 seconds now for waiting this to complete, but it'll hopefully give us some useful information. Does anyone want to do a countdown?
So in terms of trends...
30 seconds.
In terms of trends, will it run through 5 of them for each trend then?
Dan asks, with 5 users, will it run each of these 5 times? Yes. So the way I've configured this test, there's a million different ways you can configure it. You can split the traffic, so you can send some views doing something else. You can send some, you can split things up. But with this one, I do a post, I get it, and then I update it. So this test, it does what you think. You can configure it in any way you want. It's very, very flexible, the tool, in terms of managing the threading. Okay, so that is our test. So as you see here, we've got some results. So hopefully. So here's some custom metrics. So you can see here, averages. So I've hit it quite hard over a period of time, and that is my average. So on average, my getting something takes 154 milliseconds, putting something in takes 170 milliseconds, and putting something in there is 160 milliseconds. Now, of course, you don't want to give terminal output to people, so you can do what is called a report. So, Jake, I might want you to do the countdown sound again, because I'm going to do it again. So if I do, okay, that's the one. So I'm actually going to stop this. 10. Yeah, I've stopped it now. So I do 5 minutes. And I want to do case 6, part 3, and Jake is going to not tell me off this time because I am actually going to save it. And I'm going to run that. So this, and I hope I can remember the URL, 50, I think it was there. I wish I could type. There we go. Is it on that one? No. Okay, so bear with me. That would spin up a report. Now, annoyingly, most of the times it opens up the report for you, but I'm not going to be able to find it. No, so
you run it for 5 minutes.
yeah, so if I just, so if I do that, and I can grab the, you might want to cut this part out, cameraman.
Try just running it for 30 seconds and then...
No, I was just trying to remember the part.
5665.
5665, right. So if we run that again, and then if we open up 5665, come on.
Would you still be able to see it even though 5665?
5665.
You've put 5565.
I think Mo pointed out that I didn't do the thing. So this one,
Yeah, that one.
5665. Let's do it one more time, and then we'll just skip. But all it is a nice report of the stats. Hey, there we go. So give it a second to load, and that is a nice report telling you everything going on. So this is the sort of stuff you would give to a client to kind of represent performance. So it takes a bit of time to populate. But there you go. So you can see here that you've got a nice summary of all the things, and these are the sorts of client deliverables that you would have. Dan asked the question, is this going to keep updating? Now, if you're watching online, yes, it is. Sorry, Dan. So that's part 3. Maths. Okay. So performance testing is rooted in math. You've probably seen percentiles. So percentiles are your 10% worst. Like if you say, I'm looking at the 90th percentile, you're saying I'm looking at the 10% worst experience with the software, in the sense of these are the people who are going to be seeing the longest times. So if I go back to my report, I hope I didn't, you see here, P90. So my average was 153, and now the 10% worst people will get 160, the 5% will get 187, and the 1% will get 203. That's a really good thing to show to a client, because they'll think, oh yeah, the average person's fine, but someone who's having a bad day will fall into one of these categories. So like 1% here, 204. That's 203 at the 99th percentile is like saying someone's going to have at very worst 203. You have maxes as well, but you don't tend to discount maxes because you're hitting it so hard that you're looking at like a one outlier sort of thing. So you use percentiles because you're hitting it over a long period of time. What would these different percentile groups experience? Unless this number was significantly higher, they would have the same experience, pretty much the same experience. 245 milliseconds is pretty much nothing. But if that was 5 seconds, then I might have a problem where for some 1% of cases, there's a really long wait and we're not sure why. So Lucy asks if people are having like gig tickets being...
You know, like you're trying to like Glastonbury tickets or
Oh, A gig ticket, I was thinking, what's a gig ticket in IT terms? No. So yeah, it's genuinely, that's a genuinely good point, but with that one, I would expect that to be like at the 30th percentile, where like it'd be the other way around, where only a few percentage of people actually get through it fast and everyone else will be really slow. To fill the cameraman in, everyone's complaining about Ticketmaster. We just had a 20-second brief talk about Ticketmaster there.
Is there sort of performance testing that you would do to limit that you're not obviously...
Yeah, you would look at, looking at percentiles is really important. So Lucy says that's the sort of thing you would do. Ticketmaster would benefit from that. Okay, the other side is like thread management. So you know when you have to decide how hard you're going to hit a service. And you want to say, oh, we want 100 active users at once. I'm like, what does that even mean? Because 100 active users, you have to calculate the time it takes for them to get through it, to loop back. So it's kind of like it reminds me of the questions that when you were a kid at school, where if the bus sets off at 3 o'clock in the afternoon and will take 5 minutes going at 30 miles an hour, when will it arrive? And I'm just like, it's awful. It's hard to figure out. It's genuinely quite complicated mathematics around it. Yeah. NFRs are what clients often use to define how they want to behave performance. You can have really bad ones and you can have really good ones. And the really good ones are the ones that are either incredibly detailed to a point to everything's detailed, or so vague that you can kind of figure it out yourself. and the ones in between, like we've had with previous clients, where they said something like, we don't want it 5% worse, and I'm sat here thinking, what does that even mean? And a lot of it is about figuring that out yourself. And from a consultancy perspective, we often help clients with NFRs. We say, okay, how do we define what your expected performance wants to say? And a lot of the time, clients want things so perfect, as in they want nothing changed, nothing wrong, nothing absolutely wrong, that perfect becomes the enemy of good, because you can't test on production. You're often testing on environments before production, and it's like there's only so much you can do. But there is often a lot of good things you can do to help clients figure out if their software is going to work in production.
Just in terms of NFRs, what's your experience been in terms of production being completely different to a dev environment? Because obviously you've got lower CPU, you've got lower servers. In terms of how do you monitor that it's going to perform as well as it would from a dev perspective into a production?
So Dan asked the time old question of how do you compare a dev environment to a production environment, and you don't, or you often have what's called a pre-prod environment. Sometimes you don't have that, and sometimes you kind of have to provide the information that you can. Usually I tend to find there is things you still can do with limitations. Of course, you have to be very careful how you communicate that with a client, because it can often break expectation. But this is probably the most difficult part of explaining to people that things can't be perfect. Like you can't. A lot of time, pre-prod is a best go at prod, in the sense of it's not perfect, but it does. And prod, ultimately, prod config and pre-prod config might be the same, but they are two different entities, as in you set them twice, but you never know what might be different. So the last part is a nice fun feature of K6 to end it on a good note. So I have, if I can find my mouse, the last test I have is a browser test. So a more modern feature, and clients have asked for this, is what does my website do while it's being hit hard? Because we've been hitting APIs. But that's not what end users see. They see websites. They see UIs. They interact with UIs. They don't interact with APIs. So Playwright has a feature in it now, which is a browser test. So it actually runs some Playwright code. So you see here, I've got some Playwright code. So it opens up a page, it opens up a Chrome. And oftentimes, one of the recommended things for this is you have stuff going on, a small amount of threads on the UI, because browsers, opening a Chrome browser, opening 500 Chrome browsers on one machine is going to blow up your machine. So you would have a small amount of threads running the UI and a lot of things running the API. So here I've got 500 API users and 2 on the UI. And if you see in here, what it does is it takes a picture of my website every minute to just see what it looks like. So I have no idea what's going to happen here. This can only end incredibly well, so I'm just going to...
I'm hoping you've created some custom error pages that are really funny.
No. Okay, so let's...
I don't know if you want to shorten the time.
It's, I've got 2 minutes, this is the last thing, so...
It's running 20 minutes.
Are we ready? Are we all ready?
20 minutes there though, so is that...
Ah, yeah, but it'll break before then, I think. Right, here we go. 3, 2, 1, boom. So that's running. I'm gonna. I think it will work. You know, I'm confident of my development skills. So let's have a look. Oh, it's a bit slower than normal. Oh dear, it's working fine. What's going on here? So
Hopefully it's took a screenshot.
yeah. So as you can see, it's taking pictures. But my website is perfect. Nothing wrong with it. 500 users at once. Clearly. That's a bit awkward, but a good ending nonetheless. Should we just try should we do it again, but be silly about it this time? So if I...
Up it to 10,000 API VUs and...
I like how you think you're a performance tester now, Jake. Let's do 10,500, because, you know, why not? So let's try that again.
Rate your computer while we're at it.
Oh my word, I've never seen that before. Oh, my computer's... Surely this isn't working. Surely. Oh.
That's it now. Game over.
It's worked.
Oh, it's working.
I've made a really good application. What's going on? Oh no, hang on. Is that that's loading. Oh, it's struggling, I think. I wonder what my server's doing.
It's like there were occasional failures.
Yeah. But with 10,000 users, I'm not bothered, that's fine. We'll do me. Oh, there you go. Ooh.
It's trying to handle it though, isn't it?
4.1%. What? Yeah. That's a bit low, yeah.
Oh.
Is it even hitting? Is it configured to point at your blog or is it pointing somewhere else? Upside down.
Oh, hang on. Oh, that.
Production.
Oh, hang on.
I read that quickly.
Let's get rid of that problem. That is DigitalOcean. Probably going to have a big bill.
They've probably got some default
Yeah.
protection.
So I hit the DDoS protection on the thing. So there you go. All good. And on that note, I'm probably going to have a big bill tomorrow.